Is Jupiter a failed star? Is Jupiter the biggest planet in our solar system, and it holds so many secrets? Its violent nature, gas composition, and the fact that it's twice bigger mass than all the planets in our solar system. Let's first talk about parameters of this planet. This planet has diameter 11 times bigger than our Earth's diameter, about 142.9 thousand kilometers. And this planet is the largest and has the huge magnetic field and 64 moons and natural satellites that evolved around it. Many consider Jupiter as the miniature solar system, and it looks like that. Often people say that Jupiter is a failed star because it's made of the same gases as Sun, although it doesn't have anywhere near the mass or temperature to actually be a star. Jupiter needs a much bigger mass, about 80 times of current, to become a star. Back in the day, Galileo was the first to see the 4 biggest moons of the Jupiter: Callisto, Europe, Ganymede, and Io, which evolved around it. If you looked in any not that strong telescope or binoculars, you can see on a clear night those 4 satellites. Jupiter is innermost of the 4 gas giants, and we know other ones: Saturn, Uranus, and Neptune, the gas large planets bigger than our Earth. Although they very gassy planets and large, they're not as dense as our Earth-like planets. But the closer you get towards the core of those planets, the gas gets more denser. The Jupiter mass as well is enormous, 317 times of the Earth one, and 1,000th part of the Sun. Interesting that when the Jupiter was formed, it was actually much larger than now. It's been shrinking and shrinking every year 2 centimeters. The process of heating and cooling of this gas causing such a rapid shrinkage. We know that the Jupiter actually evolving not directly around the Sun's center, but slightly to the side of it. The center of the mass for the Jupiter lies outside of the Sun, and although Jupiter is large in diameter and mass, it's not as dense, and it's about only a quarter of the density of our planet. Interesting that Jupiter orbits our Sun around every 11.8 Earth years. It's tilted very small, only about 3 degrees, so we do not suggest that there is a seasons on that planet, if the seasons could occur. It's such a gaseous planet. However, it rotates very fast. It's the fastest in all the planets. It rotates around its axis every 10 hours. Therefore, the planet is bulged around its equator, and it has the shape of an oblate spheroid. Because it's so gaseous, not all of the planet orbits at the same speed. And you can imagine it has 3 different systems. The atmosphere at the poles rotates around 5 minutes faster than the equatorial atmosphere, which is a little bit slower than the rotation of the magnetosphere. Jupiter, it's not just about its size and the gas. It's a very interesting appearance. It has a lot of red, orange, white and brown bands. They move separately from each other. And the Jupiter is the 4th brightest object we might observe now on the sky for today. It's interesting that we cannot see whole the surface of the Jupiter. The angle of the light reflected from the Sun is never greater than about 11 degrees. So to see the whole planet, we have to go and visit it. We also observe Jupiter to move in retrograde manner in respect to the stars, and it's because the Earth overtakes Jupiter during its orbit once every 398.9 days. Let's talk a little bit about the structure of the Jupiter. Because it's a gaseous planet, it's mostly about atmosphere. These gases get denser, hotter under the great pressure within, the closer you towards the center. Jupiter consists of 90% of hydrogen and 10% of helium, volume-wise. But in terms of composition, there are about 75% of hydrogen, 24% helium. You will also find other elements such as ammonia, methane, carbon, hydrogen, sulfide, and other elements and compounds. We don't know much about its interior because we cannot penetrate through its very thick cloud of atmosphere, about 150 kilometers. However, scientists believe that the rocky core containing silicates and other elements will be in the center of this planet. This conclusion based on gravitational measurements taken by probes, but this model is very uncertain, and we're waiting for new data coming to us from future exploration of this planet. We know there's a big spin of the temperature on this planet. For example, in the cloud layer, it's about minus 145 Celsius degrees. It's very cold. However, the more you move towards the center, hydrogen becomes liquid and the temperature reaches 9,000.7 degrees Celsius. The core could be about 30,000 degrees Celsius. The planet is thought to have been much hotter and also much bigger, as much as twice of its current diameter when it's just been formed. And we know that Jupiter generates a lot of heat, much more than other planets, and it produces as much as heat as receiving from the Sun. What's interesting about the Jupiter that we're not sure if there are any and how it looks like the surface on that planet. Everything we see up today is the thick layer of the clouds. Let's talk about the clouds of this planet. Even from weak telescope you can observe these bands on its surface and even the red spot, one of the biggest swirl of the storm we ever observe. We know that these cloud layers are not static and they constantly move and flow. They have very complex pattern. We can see the bands of two kinds mostly, light-colored ones and dark-colored ones. The brighter ones, it's ammonia ice clouds in high areas and they're cold, while the dark belts contain thinner, lower, warmer clouds. The red and orange colors come from sulfur and phosphorus, while carbon may create some of the lighter gray colors. We can see the zones of these clouds all over. We have equatorial zone. We see the equatorial belt extending from equatorial zone towards 18 degrees north and south on either side. We see the tropical zone and less distinguished one towards the poles. We don't see any perfect boundaries between these layers. And since we're observing precisely these belts and the movements within those zones, and even the red spot, we see that they're quite constant. At the same time, there's temporally changes happening within them. Sometimes the speed of the wind changes, sometimes appearance changes. Scientists suggested that the speed could reach up to 100 meters per second, very high speed. And therefore the Jupiter doesn't have seasons, as we find out. It must have very strong weather patterns. The evaporation and condensation process of water creates dense clouds. These are strong storms, including powerful lightning strikes, mainly in the belts. A majority of the storms there tend to be very short, but there are a few major storms that have been raging for a long time. The biggest one we know it's the Great Red Spot, which have been around for at least 300 years. And there's also, we know and next to it there's a smaller red spot. Some refer it as the Red Spot Junior. Is there changes occurring in this red spot? Oh, it's quite stable. Yes, since we're observing it, we have quite consistent readings from about 1979 till today. The storm is about 12,000 kilometers wide north-south and about 24,000 till 40,000 kilometers east to west. Some suggested that originally this spot was much bigger. Its shrinking doesn't mean it's going to disappear. These clouds that make up this spot are high, and they're much colder than surrounding clouds. The darkest, reddest areas in the center is significantly warmer than the rest, and actually has a mild clockwise rotation. So we see the variation with the clouds within the spot. Sometimes they're strong, dark red and orange, and sometimes they pale. So why this red spot stay for so long? We don't know. One theory that it's continually powered by the intense heat from the planet, and there's no land masses or other formations to disturb it. And maybe it's also have been absorbing other storms in the past. One interesting fact I hope you will learn after this video is that the Jupiter has rings too. We always think about Saturn or Uranus with the rings, but actually since 70s of the last century we discover that Jupiter has his own hidden ring system. We have two outer rings, they're white, and they're named after the moons that connect to them. And material in these rings, some of them made up of particles coming off the tiny moons located within them, while some of the ring likely formed from particles sucked towards the planet from the main ring, which mainly composed of dust. And that's mostly what we know today about this planet, and there is so much to learn about this planet. We have no idea how its surface looks like, what it's composed of. Some suggested there's no actually border between atmosphere and internal material. Therefore, you kind of just dive in through the atmosphere into the denser atmosphere before you reach the core. There is so much to explore, and future exploration will give us so much information. It's fascinating how many answers future hold for us about our solar system. Please like this video and subscribe to my channel to promote my videos. And I hope I'll see you in the next videos about our solar system and our own planet Earth.